right, so we're looking at this next example. And this is a little bit easier to do if you read the question carefully and you kind of ignore the formulas that we just looked at. So when we look at this, what we're looking at is somebody's education level as well as their relationship status. So single, married, divorced, and widowed. So first, when I read this, I'm going to read it very carefully and deliberately. What is the probability a person is married? So when we look at this two-way table, how many persons do we have? We have 665. We want to know what's the probability that this person is married. So that's going to be 408. And when you're doing these, just leave your answer like that. That's perfect. All right. Now, on the next one, what is the probability that a person has less than a high school education? So the probability that the person or a person has less than a high school education. So again, how many persons do we have? 665 out of, and how many have less than a high school education? That's going to be 125. All right, what is the probability that a person, so again, a person has a high school education or higher? So when we're doing this, we're going to have 665 people, and we're looking at a high school education or higher. So what that means is that we're going to be looking at people that have a high school education or college and higher. So that's going to be 397 plus 143. Awesome. Good. So far so good. Not doing too bad. Okay, let's keep going. So for the next one, it asks, what is the probability that a person is single or married? So if I look at this, again, if I read it carefully, it's asking probability of person. So we're going to be looking at all 665 people. Okay, now here's the question. Single and married. So do I have any overlap between these two categories? I don't. So a person can't be single and married. So I'm either happy if I pull a single person out of this group or a married person. All right, next one. What is the probability a person, all right, so again, a person is a widower or has a college education. So we're looking at 665. Now, a widower or has a college education. So if I look at all the people that are widows, should be right here, and I look at all the people that have a college education, my question is, do I have any overlap between these groups? And the answer is yes. I counted these three people twice. So when I counted all 61 widowers and all 143 college or higher educated people, I counted those three people twice, so I need to subtract one of those counts. Okay, what is the probability that a person is married and has a high school education? So again, we're looking at a person. So we're looking out of 665 and is married and has a high school education. So it's not enough that we count all 408 married people, and it's not enough that we count all of the high school educated people, which is 397. We want a person to have both. So we have 240 people that fit that ticket. All right. Next, we want to choose two people from the group. We want to know the probability that we choose a married person and then choose a divorced person. So, first off, we have 665, and for the married people, we have 408. Now, what is the probability that we then choose a divorced person? Well, that's times, how many people do we have left? 664 over 84 for those divorced people. All right, these last two are going to be kind of, I don't want to say tricky, like I'm not trying to trick you, but we have to be careful. So what is the probability that a married person has a college education versus what is the probability that a person is married and has a college education? So here we want to know what's the probability that a married person, so we're not looking at everybody now, we're only picking from the married people. So out of those 408 people, what's the probability they have a college education? So out of those 408, we have 98 that have a college education or higher. Now for the next one, the probability that a person is married and has a college education. Well, that's 665 because we're looking at the total pool of all people and not just a married person. And we have 98 people that fit the bill on both of those. Great. Now for the last one, this is the very last example. An exam consists of 19 true/false questions. Suppose the probability that a student makes fewer than 2 on an exam is 44, and the probability that a student makes 2 to 6, inclusive, is 26. We want to find the probability of the following outcomes. So, at the top of your paper, go ahead and write the numbers 0 through 19. So I'll go ahead and do that right now. Okay, so here's the deal, is that if a student makes fewer than 2 mistakes on an exam, that means that they either made 0 or 1 mistakes, they have a 44% probability of doing that. They have a 26% probability of making between 2 and 16, and that's including 2 and 16. So my question for you, before we even look at the questions, is what's the probability they make 17, 18, or 19 mistakes? Well, remember, they're either going to make between 0 to 19 mistakes, so these probabilities need to add up to 100. So 44 plus 26 gives us 70, which only gives us 30% to work with over here. So the probability that a student makes more than 16 mistakes, that would be this right here. That probability, we just found it, it's 30%. The probability a student makes 2 or more mistakes, well, if they make 2 or more mistakes, that would be all of these. So that would be 26 plus 30, so that would be 56% chance of that happening. And what's the probability that a student makes at most 16 mistakes? So if they make at most, that means that they made somewhere between 0 to 16. So that means that we would add this 44 and this 26 together, and we would get 70%. Now the very last question is which 2 of these 3 events are complementary? So what that means is that when you put these together, you get the entire possibilities of the amount of mistakes they can make, and you don't have any overlap, but you also don't have any gaps. So, for example, if a student makes at most 16 mistakes, that means that they made somewhere between 0 to 16, and more than 16 mistakes, which means that they made 17 to 19 mistakes. And the question is, if I add these together, do I get all the possibilities? And the answer is yes. So what that means is that these 2 are complements. That means when you put them together, you get everything. An example of something that would not be a complement would be if a student made at most 16 mistakes or 2 or more mistakes. So if we put at most 16 mistakes, and then we added 2 or more mistakes, well, the probability a student makes 0 to 16 mistakes, okay, 0 to 16 mistakes is 70%. And then the probability a student makes 2 to 19 mistakes, 2 to 19 is 56%. So when we put those 2 together, what we get is we get 126%, which does not give us 100%, it gives us more. So those would not be complements. Just as B and C would not be complements either. So for 2 things to be complements, when you add them up together, what you need to get is that you need to get exactly 100%.